All right, my mouth counts people, let's do it. We got workout 4 from 2026, and I've got my very special pen. All right, so here we go. 171, square ABCD has a side length of 12, and a rhombus AXCY inside of square ABCD has area half the area of square ABCD. That's a mouthful. What is the side length of rhombus AXCY? Express your answer in simplest radical form. Okay. So for this one, we've got a rhombus and we've got a square. A square is just a type of rhombus. So let me get a piece of paper here. I'm not prepared. Okay. So first thing that I know for this problem is that the area of the rhombus is 1/2 of diagonal 1 times diagonal 2. And it says that the area of the rhombus is half the area of the square. So the area of the square would be 144 because we got 12 times 12. So the area of the square is 144. So therefore, it says that the area of the rhombus is half the area of the square. So I know that the area of the rhombus is 72. So now I just need to find the diagonals. So the diagonals of the rhombus, of course, go from here to here. There's one of them. So AC is one of the diagonals and XY is the other diagonal. Now AC is the diagonal also of the square. So this is a 45, 45, 90 triangle inside of here. So we could do the A root 2, or you can use the Pythagorean theorem. You know, you choose, whatever. Anyways, either way that you do it, if you're using the Pythagorean theorem to find this length, or if you're using the 45, 45, 90, either way you do it, you'll find that the length of AC is 12 root 2. Okay, so now I know that diagonal AC, I'll call that diagonal 1, is 12 root 2. And now I can find this diagonal here from X to Y. That is diagonal XY. This was diagonal AC. So half of 12 root 2 is 6 root 2. And then I divide by 6 root 2. I get 72 over 6 root 2. That is diagonal 2 or XY. I can reduce. 6 goes into 72 12 times. So diagonal 2 is 12 over root 2. All right, so now that I've got that all taken care of, I know what my diagonals are. In order to find the length of one of the sides of a rhombus, all the sides in a rhombus are the same, and the diagonals of a rhombus are perpendicular. So what I need at this point is this section, and then I can use, let's call this one C. I can now use the Pythagorean theorem to find out how long this length is. So this whole length here was 12 divided by root 2. So if I cut that in half, this section here, let's just call this A and this section B. If I take diagonal 2 and cut it in half, A would be equal to 6 over root 2. And then B is half of AC, so B would be 6 root 2. So now I can finally answer my question by using the Pythagorean theorem. So we're going to do 6 over root 2 squared plus 6 root 2 squared equals C squared. So I get 36 over 2. And then 6 squared is 36. Root 2 squared is 2. 36 times 2 is 72. That's 18 over here. So I get 90. Now that's what the side squared is. So what I'm looking for is a square root 90, but it wants it in simplest radical form. Root 90 is the perfect square of 9 times the non-perfect square of 10. And so we would get an answer of 3 square root of 10. There's our answer, 3 root 10. That's fun. Remember, these are calculator problems. So if you aren't great at reducing radicals, you can use these calculators. Oops. So if you do square root of 90 and you've got it in math print mode, it will simplify your radicals for you if you don't know how to do that. Okay. Number 172. At Al's grocery store, 5 bananas and 3 oranges cost $10.92. 4 nanners and 5 oranges cost $13.91. What's the cost of a dozen nanners? Okay, so for this one, I'm just going to write a systems of equation. I've got 5 bananas, 3 oranges. I don't like O, so I'm going to use G for oranges because I can, okay? Oops, equals 10.92. For the other equation, 4 nanners and 5 are the oranges equals $13.91. I want bananas, so I'm going to use the elimination method to get rid of the oranges. So I will multiply this one by 5. And I'll multiply everything on this side by -3. So here I get 25b plus 15g. Then you're allowed to use calculator. So 5 times 1092 is 5460. And I multiply everything over here by -3. That yields me -12b minus 15g. And then 1391 times -3 is -4173. So if I add the two equations together, the g's cancel. Over here, I get 13 bananas equals 5460 minus that is 1287. I'll divide by 13 on both sides, and a banana costs 99 cents. And this problem wants a dozen bananas, so 12 times 0.99 ends up equaling 1188. And that is my answer. Next. How many visually distinguishable arrangements of 4 lights in a single file line, each either red or green, are there such that no green light is directly between 2 red lights? All right, so it doesn't say how many red or how many green, so we could do all red, we could do all green, or a combination of red and green with our 4 lights. So there's 16 different combinations that we can do because there's 2 choices and there's 4 different choices or 4 different places to put these lights in. So we've got 16 ways total that we can do this. Now we just need to find the ways that either work or ways that don't work. So if there's 16 total ways, and I want to find out the ways where no green light is directly between 2 red lights. So you can go 2 different directions with this. You can find the ways that work, that satisfy the problem, or you can find the ways that don't work, which might be easier on this one, and then just subtract them from the total of 16 ways. So it's easier to find the ways that don't work, where we've got a green in between 2 reds. So the first thing is, what if I had 3 reds? If I had 3 reds, I could do red, green, red, red. Now that doesn't work because a green is between 2 reds. I could move that green to the next spot and get red, red, green, red. Now the green is in between those 2. Now let's look at, that's the only way to do it with 3 reds and 1 green. So the green is directly in between a red. So now let's try, what if we have 2 reds and 2 greens? So if we have 2 reds, we could do red, green, red, green. And then this green would be between 2 reds. Or we could do green, red, green, red. And then this green one is between 2 reds. That's the only way to do it with 2 reds and 2 greens. Now, if I have 3 greens, there's no way to be between 2 reds. And if it's all green, that's not going to work either. So these are the only 4 ways that aren't going to work. So there were 16 ways total. I found 4 ways that won't work. So that means there's 12 ways that do work. All right, we are moving today. The digits of the number 2027 sum to 11. And 2027 is 2 more than a perfect square. What is the largest possible integer less than 2027 with this property? Okay. So they're saying that 2 plus 0 plus 2 plus 7, they add up to 11. And 2027 is 2 more than a perfect square. It's 2 more than the perfect square of 2025. And 2025, we should know from last year and this year that this is the perfect square of 45. All right, so the perfect square of 45 plus 2 more, the digits add up to 2027. They want to know what's the largest possible integer, so the largest possible number that has this same property. Now, this is a perfect calculator problem where we shouldn't just be, grinding out numbers or guessing or whatever. We can use our table function, our equation function for this one. Let's get out of there. So we can come up with a table. We can enter an equation. So I want a number squared plus 2. So I'm going to do x squared plus 2. So that's my equation that I want to use. Got that reflection there. All right, so I'm going to hit enter. That's the equation. Now I'm going to start at 45. 45 was the first one that I squared. And I want to go down until I find the first number that also where these numbers add up to 11, where the digits add up to 11. So my step for this one is going to be -1, which means I'm going to go down by 1 each time. I'm going to start at 45, and then I'm going to just keep on going down. So that's what I'm telling the calculator to do. I'm going to go down and hit OK. All right, so at 45, something goofy has happened here. What did I do? Just a second. Okay, that didn't make any sense because I went back to my equation here. Maybe you saw this. I did x squared times 2. Oops. So x squared plus 2. Dang it, I hit the times again. Okay. X squared plus 2. Okay, now I've done it correctly this time. Okay, we're going to start at 45. Jeez. That looks better, 2027. So that's what I knew something was off. I knew it should have been 2027 up there, but it was not. All right, so now I've got, okay, if I put in 44, so 44 squared plus 2, that's 1938. Definitely doesn't add up to 11. 43 squared plus 2 is 1851. That's way more than 11. 1766, more than 11. 1683, still more than 11. 1602. 1602 adds up to 9. That is not 11. There we go. 1523. 1523 is 39 squared plus 2, and that adds up to 11. So now I know my answer is 1523. Perfect problem for using your calculators. So our answer is 1523. Almost feels like cheating. All right, Rick rolls a rectangular 6-inch by 8-inch sheet of paper up edge to edge to form a cylinder. Depending on how he rolls the paper, there's 2 different cylinders he can make. What is the absolute difference between their volumes? Express your answer as a common fraction in terms of pi. All right, so he's got 2 different ways to do this. So here's his paper. I'm going to say this is 8 and this is 6. So when he rolls it up, this is going to be the circle part, and this is going to be the height of the cylinder. The other way to do it would be to do it like this, where this is 6 and this is 8. Again, this is the round part of his cylinder up here. Okay, so I know that for this one, my circumference, that's the round part here, circumference is 6, and that's equal to 2 pi r. So the radius is 6 over 2 pi, or 3 over pi. So that's the radius for this one. Same thing over here, 8 equals 2 pi r. Divide, I get 8 over 2 pi. And so the radius of that one would be 4 over pi. Okay, so the volume of this one, we would do pi r squared, so 3 over pi squared times the height of 8. And for the other one, we would get volume equals 4 over pi squared times 6. Okay, so if we square this one, we get 9 over pi squared times 8, which is 72 over, oh, I forgot to multiply by pi. I guess it really doesn't matter. My bad. So this pi cancels out one of those pi's. So I get 72 over pi for that one. Forgot to multiply pi. It's pi r squared. Not bad. I get pi times 16 over pi squared times 6. This pi cancels out one of those pi's. So 16 times 6 ends up being 96 over pi. So I want the absolute difference between 96 over pi and 72 over pi. So 96 over pi minus 72 over pi is going to end up giving me 24 over pi. And that is our final answer. Next, need a new piece of paper here. Next one, number 176. Barter Bob sells its peanut and cocoa cluster bites cereal in a 10-ounce box for $3.49. In January 2026, they plan to introduce a new 14-ounce box priced at $4.49. From a price per ounce perspective, by what percentage has the cost decreased compared to the old box? All right, so the old box has $3.49 for every 10 ounces. So for 1 ounce, the price would be 0.349. That is the amount of dollars per ounce. Okay, so that's the per ounce price. And then the new box is 4.49 divided by 14 ounces. And I think I rounded this one before. What did I round it to? I did. I rounded this one to 0.32071. I don't know. I don't know why I went that far. I probably didn't need to go that far. So there we go. So this is the price per ounce, the new price per ounce. It's less than this one. We just want to know what percentage the decrease is. So to find the percentage of decrease, we would take the difference between these two and then divide it by what we started with over here. So we do 0.349 minus 0.32071, and then we divide it by 0.349, the original price. And it comes out, when you calculate it, I think it came out to 8.1%. Yeah, it came out to 8.1% when you plug it into your calculator. And that's our answer. All right, 177. A 5-digit number is created by using each of the digits 1, 3, 5, 7, and 9 exactly once. Each of the digits in the tens and the thousands position is larger than its neighboring digits. How many 5-digit numbers can be formed? All right, so we got 5 digits. Move up the paper so we have some room. So we got 5 digits in the tens and the thousands digit. It has to be larger than its neighboring digits. Okay, so if I place the 7 and the 9 here and here, it doesn't matter where I place the 1, 3, and 5. 1 can go here, 3 can go here, 5 can go here, because 7 and 9 are bigger than all 3 of those numbers. And since we have 3 numbers to place here, there are 3 factorial ways where I can make combinations of 1, 3, and 5 here. So that's 6 different ways that we could do it. Now we do have 6 more ways if I put the 9 here and the 7 here. So now we've got a total of 6 more ways. So I've got a total of 12 ways. But we can actually do this with a 9 and a 5. We can't do it with a 5 and a 7 because a 9 would be on either side of the 5 or 7 and it wouldn't work here. So if I put a 5 here and I left the 9 here, how many ways could I pull this off? Well, I've got the 7 would have to go over here, and then the 1 and the 3 could go here and here, or we could switch it and I could go 3, 1. So we end up with 2 ways to do it there. I could do 1, 5, 3, 9, 7 or 3, 5, 1, 9, 7. So there's 2 more ways. And then I could get 2 more ways by putting the 9 here and the 5 here. Then the 7 would have to go over here, and I could do 1, 3, or I could do 3, 1. That's 2 more ways. So I got 12, 13, 14, 15, 16. Looks like we have 16 ways that we could do that. All right, moving. 178. What is the sum of all positive integers less than or equal to 100 that have the property that their value divided by the sum of their digits is 3? Okay, so I've got basically a 2-digit number, because 100 is not going to work for this. I've got a 2-digit number where the number, let's call the number 10x plus y. So the first digit is x, the second digit is y. This is the number that I have. And then if I divide that by the two digits added together, x plus y, we should get a value of 3. So this is our number, our two-digit number, 10x plus y, where x and y are the tens digit and the ones digit. And if I divide it by the two digits added together, I should get 3. All right, so I would multiply both sides by x plus y. That would yield me 10x plus y equals 3x plus 3y. I have to distribute when I multiply over there. Let's subtract y from both sides and subtract 3x from both sides. So this is going to give me 7x equals 2y. Divide by 2, and I get 7/2 of x is equal to y. All right, so remember, x is the first number, or first digit, or no, sorry, not first. It's the tens digit, and y is this digit. So since I'm dividing by 2, x has to be a number that's divisible by 2. So let's try plugging in 2. If I plug in 2, then I end up with 7 is equal to y. So I plug in 2, 7/2 times 2 is 7, so 27. Is that divisible by 3? Yes, that's one of my ones that work. Okay, this number has to be divisible by 2 to give us an integer value for y. So let's try 4. If I plug in 4 for x, I end up with 14 for y. 14 is not a single digit, so I can't use this one. Let's try 6. If I plug in 6, 7/2 times 6 is 21. Again, my y is not a single digit, so that doesn't work. And then you're probably guessing at this point, 8's not going to work either. I can't plug in 0. So there we go. There's only one that works, 27. Done. I don't have to sum anything because these don't, there's not more than one way to do it. So it's only 27 that works. All right, 179. The sum of the lengths of all the edges of a cube is 84. What's the volume of the cube in cubic inches? Okay, so I've got a cube. So my edges, I've got 4 edges on the top of the cube. I've got 4 edges around the side of the cube. And I got 4 edges on the bottom of the cube. So we've got a total of 12 edges. So if I take 84 and divide it by 12, that would be 1 edge length. So my edge length ends up being 7. So this is a 7 by 7 by 7. So the volume of the cube would just be 7 to the 3rd power, which is 343. All right, last one. If x, y, and z are positive integers, like this, for which x plus y plus z equals 20, and x squared plus y squared plus z squared equals 222, what's the value of xy plus xz plus yz? All right, so there's a lot of things that you could try on this one. Like the first thing that I tried is I tried to add the two equations together and see if I could do some fancy factoring with that one. Didn't really get anywhere. But here's what I notice about it is these are all squares of this one. So I thought, what would happen if I square both sides to this one? So if I take x plus y plus z and square it, and take 20 and square it, what would happen if I did that? Well, this part over here would be 400. And then x plus y plus z is not x squared plus y squared plus z squared. If we set up an area model for this one, This is not very good. Good enough. And we did x plus y plus z times x plus y plus z. We get x squared here. Y times y would be y squared. Z times z would be z squared. But then this one would be xy. This one would be xz. This one would be xy. This would be z or yz. This would be xz. And this one would be yz. So I do have x squared, y squared, z squared. But then over here, I've got 2 of the xy's. Over here, I've got 2 of the xz's. And here, I've got 2 of the yz's. So what I notice is xy, xz, yz, that if I factor out a 2 from this group, here's what I'm going to be left with. I've got x squared plus y squared plus z squared. And then over here, I'm going to factor out a 2, and I would be left with xy plus xz plus yz. And that equals 400. And then by substituting, I know that x squared plus y squared plus z squared equals 222. So this whole section here equals 222. All right, so this is what I want to find for. So I'm going to subtract 222 from both sides. So that's going to give me 2 times xy plus xz plus yz. Subtract 222, and that gives me 178. And then I divide by 2 on both sides. And 178 divided by 2 is 89. So there's my number. xy plus xc plus yz must equal 89. Done. That one was interesting. Okay, so that's all the math I got for you right now. Keep mathing hard. I'll see you later. Bye-bye.